Let's discuss how ShiftLeft integrates into a pull request strategy. Our accurate and fast static analysis can be used to help engineers harden their security posture. This is an overall view of a pull request or PR strategy. For our example, we will assume that the tools we're using are GitHub, Jenkins, and ShiftLeft static analysis. Your particular environment may substitute other tools for GitHub or Jenkins. However, ShiftLeft's static analysis product Inspect has two unique features that make it the best-in-class fit for your operation. 1. Speed. Our static analysis can find detailed issues in your software quickly. OWASP benchmarks bear this out. 2. Accuracy. Once again, the OWASP benchmarks show ShiftLeft's accuracy is unsurpassed. Let's begin by defining our pull request or PR policy. Generally speaking, we will use the PRs to keep our trunk clean. That way the trunk may always be built and reliably produce a working system. By restricting what can be merged with the trunk, we substantially reduce the possibility of a failed build of our product. In this case, our PR policy is that all changes to the working system must be done on a branch. When the work is complete, a request is made by the branch's author to merge his code with the working trunk build. GitHub, shown here, allows remote systems to pass a status back to any branch after an activity completes. This menu may be found in your given repository in Settings, then Branch Protection. That status can then be used to automate the monitoring of many steps of our PR strategy. Our first check is an automated checkout of the branch and merge with the trunk. This ensures there are no conflicts with branch and trunk code. A continuous integration build is then performed to check that the merged code is buildable. Once the build is complete, this is the phase where ShiftLeft's static analysis can be used. By running a fast and accurate analysis at this point, we can let the developer know if his code is ready for testing. This is where ShiftLeft's Inspect product looks deeply into the code, and a policy determination is made as to the quality of the build. Policies like no high impact issues, or more specific policies like no cross-site scripting vulnerabilities may exist. This status is set once the fast static analysis is done and the results mechanically checked for failure. In this case, we're saying that these checks must pass for confirmation of the PR merge. Now that we have the statuses set up in GitHub, let's move to the settings and webhooks. We use webhooks in this demo to make the process quicker. We are using Jenkins as our continuous integration host. HSL pipeline is the pipeline script that receives the GitHub webhook message to initiate operation. After some minor configuration to set credentials, environment variables, and the Jenkins generic webhook plugin, we add ShiftLeft to our pipeline. Note the simplicity of performing and checking a ShiftLeft static analysis. There is no need to run ShiftLeft during the build phase, thus the build operation is allowed to run at full speed. A small Python script is used to query the ShiftLeft API to assess the results of the static analysis. If it returns a 0, the company's policy for pull request merger is successful, or non-zero if not. A policy may be something generic like no high impact issues, or very specific like no cross-site scripting findings allowed. A simple curl operation uses the GitHub API to report the status of the static analysis back to GitHub. This operation could be folded into the getStatus.py function, but for the purposes of a demonstration, we elaborate it here. I've returned to GitHub to generate a pull request. In this case, a file has been modified. We'll create a new branch that's helpfully named for us, and we'll generate the proposed file change. Whenever we propose a file change on a new branch, this initiates a pull request. You can see here open pull request on GitHub. We can add some data to it for people who may have to justify that this is either good or bad, and we can create the pull request here. By creating the pull request, we initiate the operations required to do a mechanical check of the pull that we've just created. Here you can see some operations that need to be performed before the pull request is allowed. These are the ones that we set up earlier and generate a webhook to create the continuous integration operations. We see that the build, checkout merge has occurred and there are no problems with the checkout of the repository. Jar construction is finished. We can see now that the jar has been constructed. Our Maven command to build our application has executed without a problem. After a brief time, you can see that the ShiftLeft analysis has completed. Now, this has also been checked to see that it meets the criterion that we demand for our security. And once all of the different checks are finished as part of the continuous integration operation, we can then merge this pull request. I've moved over to Jenkins so that we can observe the operation through its eyes instead of from GitHub. A request to pull new data has been issued, and we can see that the webhook has arrived already. So number 79 has begun operation. The checkout, ShiftLeft tool configuration, build, and assorted other operations are going to be completed for this particular pipeline operation. We can see from the build phase here that the ShiftLeft analysis takes roughly a minute, 26 seconds. It varies slightly depending on server load. We've now completed the ShiftLeft analysis. We do a little smoke testing, and then we're done.